Hi, welcome to Concept Based. I'm John Hepworth, and this is a Year 11 advanced topic. We are in exponential and logarithmic functions, and we're specifically looking at logarithmic functions today. Now, these can be confusing for students all the way through Year 11 and 12. They might be able to use logs, but they don't really get what a log is fundamentally. And here on this YouTube channel being called Concept Based, the idea is we want to try and make sure that we're understanding the underlying concepts so that the procedures just seem like second nature because they all make sense. So let's have a crack and see if we can understand what exactly is a log. What is a logarithm? What is it actually doing? So to do that today, we've got the first example question out of the syllabus in the logarithmic functions section, solving e to the power of x minus 2 equals 12. Okay, so first of all, I'm not going to solve this question. First of all, I just want to talk about some concepts in mathematics. You've learned to solve equations that were quite simple back in the day, right? A long time ago, you learned that you undid +1 by doing -1 to both sides, and that allowed you to get back to the x. And then, of course, things became more complex, and we ended up with something like this, x squared equaled 4, and so you had to take the square root of both sides to try and get to what that x value was. Then things became even more complex. Sine x equaled a half. And then you had to do the inverse sine function of to both sides to try and get to this x term. So this is just another one of those steps that you've learned to take to find the inverse function of what's happening, to undo it, to get out of the equation. So what is happening here in this equation? Well, here the variables are in the exponent, right? The power is the variable. So we want to get to the power. So we have to undo what has been done to it to get to the power. And the undoing of the exponential part, the raising it to a power, is the logarithm of that, right? So where you learned the square root was the inverse of squared, the inverse sine is the inverse of sine. Here, the logarithm is the inversing of the exponential function. So what we're going to do is we're going to take the log and we're going to keep the base the same. Here it's a base e, so the only way we can undo a base e is if our logarithm is base e of e to the x minus 2. And whatever we do to one side of an equation, we have to do to the other side of the equation. So we're taking log base e of 12 of this side. Okay, so when we do that, this here is going to undo the raising to the power. It's going to bring it back down to become its own base here. So essentially it's like this e is cancelling out this e here, and we get to x minus 2 is equal to, now log base e is often written as ln, the natural log, of 12. And then of course, we're just solving this equation as per usual. So we're adding to both sides, and we get x equals log 12. Now the log is only affecting the 12. The plus 2 is on the end outside of the log. Just like if you were doing this with trig functions, if it had sine theta and you added 2, it's not sine theta plus 2, it's sine theta plus 2. So that's the same in these logarithmic functions here. Now, once you get to this point here, this question in your syllabus actually asks you to answer it to two significant figures. So you then need to be able to put it into your calculator the same way you're putting trig functions, inverse trig functions, and so forth into your calculator. I'm still using the Casio FX82AU. Check out those buttons. They are completely worn out, all black. I'm going to buy a new one and upgrade it, but on the calculators, you've got a log base 10 button and an ln button, which is your log base e. So if we do log 12 and then we add 2 to our answer, we get 4.484. We wanted two significant figures, so 4.5 is fine for us for our two significant figures. X equals 4.5. Now, what you might want to do, sometimes when you do check an answer to an equation, you put it back up in the equation, you watch it work, you go, that sometimes makes more sense for you. So can we put our answer? So let's leave our answer in our calculator as essentially the answer button. And let's go and put it back up in the calculator. So what we want to do is we want to do e to the power of the answer that we just got minus 2 and press equals, and voila, 12 comes out on the calculator. So e to the power of whatever it was, 4.5 minus 2, so 2.5. E to the power of 2.5 approximately, obviously it needs to be exact because it's an irrational number, is equal to 12. Now there's another part of this that you can try and remember as well. It's this circle rule that I remember it as. So that if y equals a to the x, what we were saying is you have to take the log to the base a of both sides to undo it. So log base a of y equals, if we did log base a of a to the x, it would undo the a and we'd just get x. So what it's actually saying in these two forms, these are equivalent, these forms, right? Because we've just changed that the subject of the equation in these two steps. So if you're trying to work out what's being said in the log part of this step, you can use what's been said in the first part. So how does this relate to this second part? Well, a to the power of x is equal to y. So I often try and remember logs using this idea that a to the power of the answer, the base of the log to the power of the answer, is equal to the question. That might help you have a better conceptual understanding of what's actually happening in these logs when we take these logs. A to the power of the answer is equal to the question.